Say you're developing a game. In this game you have this hero that needs to navigate through a maze while avoiding monsters. You decide on a hero class with three different functions. The move to function to move through the maze, the take damage function that the monsters can use to inflict damage on the player, and the draw function that can be used to render the player. As such, you end up with three different clients communicating with this class. The controller client, the monsters, and the renderer. From a software engineering perspective, there are many problems with this design. Perhaps most importantly, the fact that these three clients, the controller, the monster, and the renderer, now all are tightly coupled to this player class. For example, the renderer class does not need to know that it is rendering a hero. It should be able to draw heroes, trees, monsters, anything else that might be in this maze exactly the same way. So the first thing we're going to do is introduce an interface. We'll create an entity interface that abstracts away from the fact that this particular entity is actually the hero. Now we end up with a typical violation of the Interface Segregation Principle, the fourth of the solid principles. This principle states that you should segregate or split your interfaces such that the clients using those interfaces don't depend on any functionality that they do not need. In this case, for example, the renderer does not need the move to function to be available, because the renderer is just going to draw things, it's never going to move things around. Why is this a problem? Well, consider what would happen if somewhere during our development cycle we decide that this move to function is actually really inconvenient. It would be much easier if we just have a move in direction function, which you can just pass a direction, up, down, left, right. Now, if we make this change, then suddenly all the clients that are reliant on this interface are impacted. This is understandable for the controller because we are introducing different controller functionality. But why should the team that's working on the renderer have to recompile all their software, maybe even redeploy it if it's already deployed somewhere, maybe a staging environment? That's why a much better design would be to split up, to segregate this entity interface into three different interfaces. We'll have a controllable interface that's used for anything that is controllable, a damageable interface. Maybe we have trees in this maze that the player can chop down to create new paths, then a tree can also be a damageable. And then there's the drawable interface. Well, clearly this is an interface we can reuse for many things. As you can see, by splitting up this interface, we not only make it such that the clients don't depend on functionality they do not need, and hence are not impacted when this other functionality is updated, but it also makes it much easier to reuse these interfaces for different parts of a software without violating the Liskov substitution principle. So here again we see that all these different solid principles work together to point us in the same direction when it comes to good software design. Now, of course, the most important question when it comes to interface segregation is, how far should you go? You can, of course, make every single function into a separate interface, then you'll be perfectly segregated and your clients will never depend on things they don't need. But if your client needs to talk to 5 different interfaces to do its job, then this will also make it very hard to implement this client and result in more complex software. So it's up to you as a software developer, as a software engineer, to think about what different use cases there are, how clients are going to interact with your software, and based on that, decide how to segregate your interfaces into things that nicely describe exactly one bit of functionality. After all, that's what a good interface should be, something that describes the behavior of the underlying class. So, in summary, the interface segregation principle tells us to split up our interfaces such that the clients using those interfaces don't depend on things they don't need. By doing this, we make sure that changes to interfaces only impact the clients that are actually using this functionality. And as such, it makes our software more maintainable. In the next episode, we'll talk about the last of the solid principles, the dependency inversion principle. Arguably the most important principle, that it helps us to decouple our software and makes many of the other principles more easy to implement. Thanks for watching. I'll see you then.